For anyone joining us for the first time. Walkingtree Technologies is a technology focused company with a core focus on designing and building cross platform web and mobile applications, perform system integrations, enable digital transformation. We also specialize in data integration, data analytics, migration from legacy to modern systems, cloud migrations, and of course, perform UX design. Now, apart from the end-to-end application development cycle, we also provide custom solutions to enterprises for web and mobile. For example, very specific services within the software development lifecycle, like UI, UX design, microservices, DevOps, and cloud. Our flexible staff augmentation services provide clients with on-demand skills and resources to help meet organizational and business objectives. And lastly, we also help you to implement certain solutions like we have done with Digit, which is an open source platform for urban governance. Today we have two presenters. Suman is the VP engineering here at Walkingtree. He has a total experience of over 14 years now in designing technology architecture and guiding teams in agile technology. And Shubham has been with us here for over 3 years now, I guess. His core strength lies in DevOps, analytics, AI, and machine learning. So over to you, Suman.
Thank you, Pranshu. Thank you all for joining the meeting. I'll briefly cover the agenda, and I'll be covering the need part. Why do we need to use external configurations? And the rest of the stuff will be covered by my colleague Shubham. Okay. So the agenda is that why is external configuration needed? So why do we need to have some external configuration? What kind of scenarios pushes you to configure to have the external configurations? And a lot of you might have already solved this problem in the typical non-containerized standard deployments. So that's why we are not covering those things. So we will be directly jumping into how do we handle that in the containerized environment. So we cover environment variables in Dockerfile and how to link those Dockerfile environment variables to Kubernetes. And then we cover about config maps, the concept specific to the Kubernetes. Then we'll be covering the secrets within the config maps, secrets is other concept, acts like a config map. Then how to pass a default configuration values from the image itself, that means through Dockerfile. Then finally, we'll provide a brief summary on the overall entire topic that we have covered. Okay, so that's the brief agenda. So without wasting further time, let's get into the real stuff. Okay. So why is external configuration needed? So that's a question that comes for a lot of people, or at least if you are maybe relatively a junior developer or a mid-level developer, you may have this question. But as you move up, you will not have this question, because by the time your seniors or architects might have taught you that, okay, you need to have the external configuration. Okay. So you see a application here, like why external configuration needed. So this is kind of, you see, it is a practical case in all of your environments. Okay. You'll have a single code base. Okay. And that single code base is catering to the different environments. Okay. So in your application, you'll have a test environment, UAT environment, production environment. Okay. Some people will have more environments like dev environment, performance environment. Okay. But all these environments, right, code may be same, but each environment will have their own specific attributes, like entities. Example, database. So test environment will have its own database. UAT will have its own database. Production will have its own database. Same case, example, in case you have some third party integration, maybe simple example could be payment gateway, right? So payment gateway for the production will be different. For payment gateway for test and UAT will be different, because you cannot do a production transactions in test and test transactions in production. Okay. So what happens, even though the code is same, but the external entities that you connect, or maybe some behavior which needs to be changed based on the environment that you are running. Okay, so this is a common case. It is not that new anything, but it's a common case. Okay, it is a common case. And the challenges, let's say, what are the challenges if you do not maintain the external configurations? The challenges primarily is that, let's say, if you don't code, if you do not externalize the configurations, then you need to maintain a separate code for each environment. That means, like, let's say, test environment. Okay, you need to configure the every time when you're trying to build an application, you have to build separately for the test. And same case with UAT, same case with production. Okay, so configurations, if you don't externalize it, you'll have a lot of challenges. If you externalize the configuration, it will solve a lot of challenges. Okay, so I covered a couple of challenges that will solve if you externalize the configuration. So single artifact, that means you can have a single artifact that can be used across multiple environments. Okay, you do not need to generate a separate artifact for each environment. Then second is avoid rebuild. So whenever some configuration change happens, if you externalize the configuration, you do not need to build the artifact again. You do not need to build the corresponding jar, var, or a Docker file. You don't need to do a rebuild. Okay. Then a single responsibility principle. That means when developer is making a change, he should make a change with a single responsibility, not with multiple responsibilities. Okay, so if you externalize the configuration variables, so developer will be making a code change all the time with a single intention to enhance the functionality, but not for any other reason. Okay. Then other important aspect is that if you have to enable a continuous deployment, then if you externalize the configuration, it will facilitate easy transfer, easy movement to the continuous deployment. Okay. So these are the challenges to solve. And some of the application parameters, that means what are all the things that qualifies for the external configurations. Okay, so database credentials is one example, and the log level. So log level also, let's say, should be an external configuration. Let's say if you make a log level as an internal configuration, whenever you want to increase or decrease the log level, you'll have to go and build the entire artifact again and deploy it. By the time you lose a lot of time. Okay, you may not even uncover the bugs as well. Okay, and the example is locally. That means like what language that your application is supporting, or many times you need a date format based on the, let's say if you're preparing a product, the product will have a date format changed based on the where it is deployed. Then localize also an important thing. Okay, these are like, there are samples like database, logging level, local are simple examples, but there are many things. Let's say sometimes you'll have some configuration that you say true or false. That configuration is true only in the test environment, but in the production it will be false. Okay, or another example that I covered in the previous slide is a payment gateway. Okay, or any external integrations, right? So like this, many sample application parameters or configuration parameters that we can externalize so that our application will look clean, and the overall life cycle of that application is also look very easy to maintain. Yeah, go to the next slide. So let's say now the question comes, okay, as we decided, okay, we have to go for the external configuration. So what are all the things that we need to consider? Okay, so important aspects that we need to consider is that two aspects, the storage and security. Okay, as we decided, we will externalize these configuration variables, and where do we store them? So far, if I internalize it, I'm storing it in my code itself, in the code itself. But now if I make it external, where do I need to store? Okay, that is an important aspect. The second is the security aspect of it. So if I start storing it, if I keep it in some place which is not so secure, if people get access to them, then important information will be leaked and people can play with our application as well. Okay, so when you are externalizing your configuration variables, you need to be ensuring you need to be clear on where you are storing it and how secure they are. Okay. Security could be anything. That means you may still like to store it in the code base itself as a separate variable, separate properties file. But then if that code base is shared across multiple developers, or maybe the code is available to the external people, if they look at those configuration parameters, if they are not encrypted, you may have a challenge, because people can see the configuration parameters directly. Maybe DB password will be leaked automatically if people see and look at the DB password through code. Okay, so securing and storage is important. So in the next slides, Shubham is going to cover how effectively we can store those environment variables and how effectively we can secure those environment variables, primarily in the containerized environment. So in Docker and Kubernetes, how do you manage these external variables? How do you secure them? Okay, thank you, Shubham. Over to you.
Sure. Hi everyone, welcome. This is Shubham Bhardwaj. In the slides from here, I'll be covering how do we prepare the Dockerfile of an application. How do we have an application and we make a Docker image out of it through a Dockerfile. The application has certain configurations which need to be externalized. How do we do that? And while deploying, what do we exactly deploy? Where do we keep our configurations? How do we differentiate between the configurations which are non-sensitive and the configurations which are sensitive? And then at the end of it, I'll provide a summary of it. So the first thing is, as we are talking about containerized environments, we have an application which we want to deploy inside our containerized environment. We'll create a Docker image for that, and for that we'll require a Dockerfile. So what I show here is a sample application, is a simple Dockerfile for an application which is based on a var, application.var, and that var is copied. It's a Java application. That var is copied inside Tomcat folder inside your container, and this application uses some configurations. It has a data source for which it has a username, password, URL, the database platform which is being used. It could be MySQL, it could be Oracle, it could be Postgres. It has the corresponding driver class for that database platform. It has one example of another configuration which it has is the logging file name. So what name the logging file should have. This is something which people may like to configure based on different scenarios. And another example is of a configuration is that it uses here is a locale. So what language, for example, would you like your application to be displayed in? So this is a Dockerfile which will be when we will be passing these configurations, when we want to deploy our application which has these configurations, we will, to start with, build a Docker image which has all these configurations: username, password, URL, platform, driver class, logging file name, and locales as environment variables specified to start with in the Dockerfile. If you don't specify the environment variables here, there'll not be the application will not have external configuration. So this is a Docker file. I'm building the Docker image by using Docker build, and the Docker image gets generated. And when I run this Docker image and I go into the container, I'm able to see certain variables. For example, you can see the application.user locales. I set it as English while running the container. You can see the Spring data source URL. I gave a simple URL. You can see the logging file name as application.log. While running it, I provided that as a logging file name. You can see other parameters, other configurations like Spring data source password. The rest of the configurations are the default configurations for your Tomcat application. Now, when we have this Docker file and we want to use it in our cluster, in our application cluster, Kubernetes cluster, we'll be using it through a deployment. We will be, of course, a Docker image is created and that needs to be integrated into the cluster, that needs to be deployed into the cluster. And at the same time, we have to ensure that that deployment is able to extract the values of each of the environment variables. So what you see here is a deployment manifest for my application, and it has the main container image has certain environment variables associated with it, which I showed before here. So all these environment variables, 6 of them, will be passed as environment variables here inside my application manifest, deployment manifest. And if you note, in this case, I'm rather providing the name of the configuration of the parameter and the value. So the value is kind of being hard coded here. You have the data source URL for which the value is being provided, same for username, and so on for other variables, other configurations, the password, database platform, driver class, logging file name, and user locale. So this is one way in which this can be done. Here also, it is a configuration which you are keeping in your Kubernetes cluster. You are using environment variables for that. But the problem with this is, if every time you have to change this configuration, every time you have to, suppose you move from production cluster, from test cluster to UAT or to production cluster, and you do the redeployments. So you will have to go to the Kubernetes deployment file, the deployment manifest, and you will have to change the values of each of these environment variables. So this is still an inefficient process. The beauty is, if you can, I mean, this is still a better case than you doing this, you rebuilding the image every time. So for example, if you don't provide these environment variables here, if you don't externalize them through Dockerfile, you will have to rebuild your application every time. The war file will have to be rebuilt every time with the respective values. So you will be hard coding them in your application. That part is eliminated. Once you make them as environment variables, you will not have to rebuild your application every now and then whenever you require a new configuration, whenever you move from one environment to another, or all scenarios that my colleague someone has listed. However, despite that part being taken care of, the issue is still, one of the issues still remains, and the issue is that those environment variable values still need to be passed. They still need to be changed every time in the deployment that you do. So a more efficient way of doing this would be, rather than keeping these values as environment variables, fetching them as environment variables inside your deployment, we would rather maintain them in a separate resource, and that resource would be a central resource which can be referred to not just in one deployment, in multiple deployments. And even if you redeploy your thing, as long as you modify the basic resource, the redeployment is successful. You don't need to change variable every time. So for example, if you have the same deployment working in different clusters, or even in the same cluster, you have different deployments using some environment variables, you need not go to each and every deployment and change those environment variables. You can simply do that in that central resource. And that central resource, depending on what kind of configuration you are working with, what kind of parameters you are coding, if you are coding sensitive values or you are coding non-sensitive values, the resources are different for the two cases. So if we talk about maintaining variables which are non-sensitive, for example, I show here the database platform or the driver class name or logging file name. These are not necessarily sensitive values. And these can, if somebody wants, for example, if someone were interested in looking at these files, revealing of these values hardly makes for any security breach. So these values can be collated together and packaged into a resource which is known as a config map. So what I show here is a Kubernetes config map. The kind is config map, and it is named as application config. And in that you see four environment variables, four data values: the database platform, the driver class name, the logging file name, and the application user locale. And these values will then be referred to by a deployment file. However, if you have something which is sensitive, for example, your database password, or in some cases, even the username may be a sensitive piece of information, your URL, database URL, where the server it is hosted on, and your database is hosted on, and the name of your database. And there could be lots of other examples. So for example, someone was talking about payment gateway. So for the respective merchant, what is your ID, what is your username and password, what is your access code, all those things. It would be a great security breach if those things are maintained unencrypted in your config maps, and anybody who has access to your config maps would be able to see those things. So those things are maintained through another Kubernetes resource, which is known as secrets. There are different ways of generating secrets. I've shown one way here, whereby you generate secret using a standard kubectl create generic command. So the application credentials is the name of the secret which is generated. And I'm just using, I'm doing the secret generation using the from literal uh, command, where I'm passing my original values. And these original values, when you do a kubectl create secret for them, a secret file is generated. And if you see the secret file, everything, the DB URL, the DB user, my password, all of these are encoded, they are encrypted. So even if somebody were to have access to the secret file, uh, say these were maintained in Jet or in Bitbucket or any other code repository, even if they were accessible, you wouldn't be able to retrieve the actual values, because the entire encryption decryption is stored in your Kubernetes cluster, which anyway is your own thing. So if somebody has access to your Kubernetes cluster, your entire thing is anyway goofed up. But as far as your code base is concerned, uh, the going of this manifest file, the secret manifest inside your Kubernetes cluster, is a safe thing. So now, how do we make use of this inside our deployment? What you see here is the same Kubernetes deployment what I had shown earlier. So the difference here is that in the previous case, I was referring to each environment variable one at a time with its hard-coded value. What I do in this case now, rather than referring to the hard-coded value of each environment variable inside the deployment file, I make a reference to the respective config map or to the secret which is created. So if you see here, I show two environment variable values, which is the data source URL and data source username. And the values for this come from a secret, which is the application secret, and I'm calling it secret key reference. So the DB URL and DB user credentials come from there. And the other credentials come from your config map, which, for example, the driver class name, the logging file name, the user locale come from your config map, and the resource required to access the reference to access them is config map key reference. For secrets, you use secret key reference. So when you do this, you have a couple of advantages. The first advantage obviously being all your all your variables, be they go to config maps or be they go to secrets, depending on whether they are sensitive or not, they can be centrally maintained. So whenever you want to change something, you go and make the change there rather than going to each deployment manifest, looking for that variable and making that change. Uh, the same config map and secrets can be used for multiple deployments. You will not have to create specify those values for different deployments every time. So for example, you may have an application which has different services, and those services share some common values. So you may have an application which has a web service component and a database component and other components which are required to run the application. And all those components may have may share some common configurations, and some other configurations can be different. So in some cases, as someone was mentioning, when it comes to different environments, test environment, production environment, all what may be different may just be a parameter. The parameter may have a value true in test environment and a value false in production environment. So those are the cases where you have common configurations, and a good number of configurations is common in different environments. Those are the cases where you have a lot of your manifest files referring to those common configurations, even within the same environment, depending on what kind of application you have. If your application is a microservice application, which, so there are many microservices running in that application, they want to refer to the same standard set of, some common standard set of configurations. Suppose you have, say, 80 microservices running in your application doing different tasks, and there are some common configurations which their deployment manifests need to maintain. It will be entirely inefficient if each deployment manifest has its own environment variables hard coded. So if at all you go for redeployment, you'll have to go to each deployment manifest and change them. So the better thing is to maintain them centrally and to refer them for each deployment you want to do. So if you maintain them centrally, if you maintain these values as your config map or as your secret, as you see here, here these are config maps. So I can use the same config map in 10 or in 20 years of deployment manifests. And if at all some change is required, I'll just go here and make that change and do the redeployment. So I'll not have to go to 20 different manifest files, or I'll not have to go to some other environment to change the manifest file. If at all some change is required, the config map will be updated, or the respective secrets will be updated, and the same change will be reflected. So this is useful in also useful in those cases where, for example, you want to change certain values in between. And for example, I may have an application which, in this case I've mentioned, is using a particular language for display. There may be other, for example, you have Spring parameters in Java-based applications, and you may want to change the values of those Spring parameters. You may want to change your the name of your log file. For example, you may have an application in which the requirement may be that the log names which your application generates, they should match with the pod name. So an expectation may be that whatever logs the application generates, those logs should be traceable to your pods. So when a pod goes down, a new pod comes up, a new application log should be generated. Now, if you go by the conventional way, where you have your log name stored in your hard-coded in your application, in your reporting.war, or in the, if you're using some other, if there is something else which is required for building of the application, so you may have some code base which is used, and in that code base, you are internally hard-coding the name of the log. Your log could be application.log. And now the requirement is that to be able to better manage and trace the history of our application, as to whether a pod, when a new pod came in, a pod went down, or a deployment failed, in all those cases. So Kubernetes clusters are obviously, the resources in Kubernetes clusters, they may change from time to time. Resources as in pods may come up, go down. Your deployments may require redoing, and all those kinds of things. So if there are resources which you want to link to your Kubernetes, if there are configurations which you want to link to your Kubernetes cluster resources, so as to be better able to trace history in terms of your deployments, in terms of the actual instances, in terms of the nodes where your images, etc., were running in the container. Those things, if you go by the conventional way, you'll not be able to do it. And if you don't do that, the travesty is that we'll lose all that history. So you may have logs of your application available, but you'll not be able to appreciate which instance was involved in generation of those logs. And that may be a very worthwhile piece of information. However, if you use config maps, so the example which I'm taking is, for example, if you want to ensure that your application has the application log has the same name as your pod name, then what you could do is you could go to your you could go to your Dockerfile, and you could define a variable. For example, for pod names, you have the standard variable my pod name, my underscore pod underscore name. And as you know, that standard variable my underscore pod underscore name is used by Kubernetes to fetch the name of the currently running pod. When you make it as a parameter in your Docker file, when you build a Docker file and then do the deployment, what happens in that case is whatever deployment is running, whatever pod is running, the value of that uh, uh, pod name or image name, and whatever you want, will be dynamically fetched based on the running resource. And with that name, you can create your respective resources. You can create application logs. So this thing would not be doable in the conventional scenario. And the example which I just gave is one of config maps. So if you, for example, you want to maintain your application logs as corresponding to the pod logs, that is not something you might like to keep secret. I mean, it's not a sensitive piece of information. But then if you, for example, had other cases, for example, someone talked about the payment gateway, and I certainly did refer to the database credentials and other things of that kind which require security, you would rather do it through secrets. So when you have these secrets and Kubernetes manifests generated and config maps generated, you don't require to pass those values again and again. That said, it doesn't necessarily mean that every value you would go and encode as config map every time. So there are values, for example, there are applications for which every application will be used by a customer, and customers may want to have certain configurations for those applications from their side. So for example, if you are providing a service to a customer, the customer may like to choose what database, what kind of database service he wants to use. He may like to choose, well, his username and password for a database service, but he may not necessarily be interested in maybe the mail service you use to send a mail to him. He may not be interested in the connection timeout, in the right timeout, or whether what the host is, what the port is. So all these are configurations, the Spring variables, the Spring Boot configurations, which are uh, important nevertheless from your application perspective. And these are environment variables certainly, but it's not required that you necessarily make them as config maps, because these can be hard coded. If at all there are configurations whose values you may require to change, they can still be put as config maps. For example, whenever your application is deployed, you have, if it is, say it is a Tomcat application, you will have Tomcat logs generated for it. So what I talked about earlier was the uh, log of your main application. So if it is a reporting application, it will have its reporting logs. If say you are running Pentaho or say Power BI or Tableau, that will have its own logs generated. But and those logs they have very important information associated with them. But when you deploy this application and run them in pods, when your pod comes up, the pod has its own log associated with it. So Tomcat is running, Tomcat has its own logs associated with it. Now those logs you may still want to store again for your future reference, again with the names of resources attached to them. So that is a Spring Boot, that's a Tomcat thing, it's a Java Spring Boot thing, which you may still like to configure. But and for that you may still go for config map. But for all other values in general, which are hard coded, which you think will not be changing from one environment to another, you need not go for specific configuration. General configurations, hard coded configurations will suffice. So as was discussed earlier, we have in external configuration is required because when we have external configuration, only then it is possible to be able to do certain things. So if you don't have external configuration, you will have to maintain different code bases for different environments. You can't have the same artifact. Your developer will rather be involved in changing the required resource files for each environment separately. So that centrality of configuration is lost when you don't do external configuration. Of course, in that case, you have to redeploy your application every time with the updated values. The bigger your application is, the more the services you are running, the more environments you are catering to, the harder it becomes. So external configuration takes care of that. And depending on what kind of external configuration you want to do, I mean, depending on kind of the data you have, you may go for secrets or config maps. Of course, the only purpose of going for secrets is you want to encrypt them, and you still want to have the encrypted value be available to yourself, maybe in a Git repository or Bitbucket or somewhere else. If at all nobody is able to access your Kubernetes cluster, and one can ensure that these values may simply reside inside the cluster like config maps, but one cannot guarantee 100% security. So it's absolutely essential to store them in an encrypted manner. And as I mentioned, these values not necessarily be encoded all the values not necessarily be externally configured every time. There are times when your customer doesn't really bother what environment variables you use. He has a particular choice of external configurations which he may like to provide you feedback on, which he may like to fill for you. For example, when you provide that application to him, he may like to enter those values which he wants to customize. But there are a lot of underlying parameters which don't require customization, and they may better be hard coded. So this was my presentation on implementing external configuration in Kubernetes using config maps. I would like to summarize the process once again. So to start with, you have a non-containerized application. You have some external configurations you may have some configurations there as well. What you may be doing is, if you have an application which is running on your local system, you are not running it as a Docker image, you are running it on your local system. Say you are running a reporting application, say Pentaho on your local system, and you will still define some variables, some environment variables. You'll define the Java home, you'll define the heap size memory which you want for your application to run. You will export all those values in your system. And everybody else who is running that application will do that on their system. But when you want to containerize your application, and the benefits of containerization are many. I mean, you want to deploy multiple applications inside, and you want to ensure good availability of those applications. Your own system may not be so safe as deploying that on a cluster which is high availability. And of course, there are tons of other advantages too. So you would go for containerizing of those applications. And once you start containerizing those applications, all those environment variables which you rather export or set on your systems, they get uh, into your Dockerfile. You Dockerize your application, you build a Docker image, and when finally you build your Docker image may still run on your local system. So you may have a Dockerfile, you may create a Docker image out of it, albeit with parameters, environment variables. You may run it on your local system, and those variables, you can pass those variables from your local system. Those variables will uh, become accessible. They'll be there in your container, and you can see their values. But at the end of the day, it's still as good as running the image without a Docker container, if you are not going to deploy that image inside a cluster. Because of course a cluster provides many more advantages, and you need not just have one application, you may have many applications, and a cluster will be helpful there. So your resources, if you, for example, if you want to increase your instances, if you want to increase pods, if you want to decrease them dynamically, if you want to bring up new instances, new nodes, etc., all those things can be taken care of there. So for that you'll have to create manifest files, you'll have to create deployments, you'll have to create services, you'll have to create ingresses, etc., when you go for Kubernetes deployments. And once you have your Docker file, and from there you want to go to your Kubernetes deployment, you can still, as I mentioned, uh, maintain those deployments using hard-coded values in environment variables. But uh, as I said, the more deployments you have, the more environments you have, it becomes too unwieldy. And more than the unwieldy part of it, it becomes inconsistent. If by mistake you miss changing the password, or you miss changing the database URL in one of the config maps, sorry, in one of the deployments, it can cause a disaster. So it's not just for the sake of ease that the centralization of maintaining the parameters is required. It's for ensuring security. It's for ensuring consistency and the associated issues with that. And when we centralize these things as config maps or as secrets, we can refer them in our deployment manifest and proceed with it. So of course, if you change the value of a config map, your config maps, the values in your config maps may be generated various ways. So I did show you how a secret file can be generated, but what you see here is a config map can be generated various ways. So you may have, your customer may be providing you through an application form some values which he may like to configure, to customize, and you may take all those values and store them in a template file of yours. And then you may have some script, you may have some Python script, you may have some Go script, you may have some script in some other language, which reads all those values and packages them in a config map for you, and further incorporates that config map maybe in a higher packaged service like a Helm chart, and you deploy those applications using Helm. So when you deploy your config maps and secrets, both config maps as any other Kubernetes resource, config maps and secrets can be incorporated in your Helm charts along with deployments, ingresses, and services and other Kubernetes resources. And when you deploy them using Helm, so what happens is the values get picked up. Now, if, for example, you want to change some value, then you'll still have to redo the deployment, but that redeployment will be done centrally. You won't have to actually go to each environment variable inside each deployment file and do that. That's a far easy thing to do. Deployment, of course, if a change is done, that needs to be done. So this was my presentation on externalizing configurations through Docker parameters through Docker through Kubernetes. And if there are any questions, we'll be happy to address them.
Thank you, Shubham. We actually do have a few questions. So if you can take a look at the chat, we have someone from Walkingtree asking, is there any way that Kubernetes can read my properties file automatically and make use of them in manifest without providing the values manually?
Is that what is the first? So is that the first question? As I hope you can see my screen. The first question is, let's say I have an Nginx web server running. Is that? Or
Oh no, if you can look at chat.
Sure. Let me. So this is the Q&A part, and
Okay, no, and you have chat. Then the other one, yeah.
this notes.
Yes.
All right.
Okay, not notes. What I'll do is I'll just copy paste this.
Maybe you can copy paste here.
You're not able to access that.
So sorry, I have Q&A, but again, it's 4 only. So you may copy.
Okay, fine. We'll look at the ones in the Q&A box first. We'll get to the chat.
Let me address that nevertheless. So your point was, say that again. You have.
Is there any way that Kubernetes can read my properties file automatically and make use of them in manifest without providing the values manually?
Is there any way my Kubernetes can read properties file automatically
and make use of them in manifest?
Well, but this is what it all does anyway. So your properties file, for example, you may have an application.properties file in your application in a non-Dockerized environment, non-Kubernetes environment. When you Dockerize it, your application.properties goes away, and then it is available. It is to be made available as a config map. Now your config map is again derived from a template. But once you derive it from the template, you go and store that inside your Kubernetes cluster. It becomes a resource in your Kubernetes cluster. Once it is a resource in your cluster obviously will read it from there. So the only additional point which I might like to make here is, between the end goal of maintaining your resources as in the configuration parameters, as config maps, and fetching them. So you may have this additional step whereby you fetch them from where they have to come. Maybe you fetch them from your customer, or your developer provides them, and you generate the config map. So the generation of that config map, one wouldn't ideally like to go to Kubernetes cluster and go and edit a config map there. That may not be appreciated, and certainly not if you have different environments. But an easier way of doing it, a better way of doing it, is to have a script which does that automation for you. So long as you have a script which does that automation for you, which generates config maps for you by taking, so for example, you may have a Jenkins job which takes parameters, and that Jenkins job internally calls a script, a Python script, a Go script, a script in some other language, which generates your config maps. So externally, you only have access to that Jenkins script. You play with that pipeline and you provide your variables. Once you do that, the control goes to Kubernetes. Your config maps are updated. Once your config maps are updated, Kubernetes by itself will pick those config maps. You will have to redeploy your application, because the application at any given point of time is running with a certain config. When you redeploy your application, your pods get recreated. They fetch the updated configs. But as long as you deploy the application, you deploy your config map, you ensure your config map is available inside cluster, Kubernetes is ready to use it. There is no other missing link there. Can you move to the next question?
Yeah, just to extend Subham's answer, Kubernetes has a mechanism that when you're creating a config map, you can pass an input file your properties file as an input to the config map. So if you have your properties file available while creating the config map, a config map can take a properties file as an input, and that properties file can become a config map in the Kubernetes cluster.
So that's through using volumes. So that properties file can be
Yeah.
incorporated inside a volume and can be used from there. Correct. So that is helpful. So either we so it's about how you at the end of the day go and generate a config map resource. You can generate it externally using some script, or you can rather, as Suman mentioned, you can take that properties file straight away with obviously the environment variables specified accordingly, so that they may be they have to be such which could become environment variables in your pods. They should maintain a standard format. As long as that standard format is being followed, it's all fine. That properties file can be used in a volume, and that volume that can be specified in a volume, and that volume can be read by your deployment manifest. So what's the next question?
From Amit, do we need each deployment manifesto for each environment?
Do we need each deployment manifest for each environment?
Manifesto, yeah.
Well, you see, so depending. So let's assume you have two clusters. You have a test cluster, a test environment, and a production environment. And obviously, the only difference between them is, or rather, the main difference between them is that your test environment is used for development, and it's only the final thing that you go and deploy in the production environment. And but at the end of the day, it's the same application. So you may have some services in the test environment which are there for development purpose, which are used there for testing purpose, which you may not put in your production environment. But the basis, your production application needs to be first tested and then deployed to production. So the same manifest will go there. So if, for example, if you have a payment service in your production application, you would rather test it first in your test application. So the deployment which you will use for your test application, as regards its basic structure, you will have the same deployment in your production application. Obviously, if you go for a different deployment, except for the config for the environment variables, if it is not tested in test environment, it may as well break in the production environment. So the ideal scenario is that a production in different environments, say if it is test in production, they have the same manifest files if you are at all running the same application, and it needs to first go through the test environment, get validated, then go to the production environment. That said, obviously the difference in deployments will come from the config maps rather from the values in the config maps. So config maps will vary from one environment to another, but the broad structure of the deployment file will be the same. May I have the next question?
Right, from an anonymous attendee. Let's say I have Nginx web server running and I have to update the proxy pass setting for every new deployment where I have Tomcat running as backend application. How can I pass that using config map?
I have to update the proxy pass setting for every new deployment. Proxy pass setting. So, well, I'm afraid I'm not 100% sure what this proxy pass setting is. But if at all, at the end of the day, if it were a proxy variable, if it were an IP that you might like to dynamically change. For example, if at the end of the day a data source URL is also has an IP, and the database name associated with it. So if it is anything which you might like to change at runtime, depending on your environment, you can extract it and make an environment variable out of it and deploy that. So obviously, you will need to create a Dockerfile for your respective application. In this case, for the Nginx web server, in the Dockerfile, you'll have to have that proxy pass setting available to you as an environment variable, and you will rather build a Docker image, and in your Kubernetes manifest, you'll have that variable. In your config map, you'll have it. So, but broader point is the same. Whatever your application is, so whichever value you want to parameterize, you follow the same standard. So I'm afraid I'm not very sure why this question on proxy setting would require something necessarily different. If the questioner could maybe elaborate more or provide some additional information, I'll be happy to consider. I'm using service to service communication, and for every deployment, I'll have Nginx front-end service, which is having some proxy setting that I'm updating for every new Tomcat application deployment, which is my backend in my case. So I want to know the way where I can pass the backend detail using
Are you able to, in your current Tomcat, are you able to read this as external parameter? If you are in your in your Tomcat environment, if you are able to read proxy pass as external parameter, then you can make that as a config map. Okay. So if you've already externalized this proxy pass in your Tomcat, converting that into config map is a straightforward process.
In that case, certainly.
So you do not need to build a Dockerfile for each environment. So you can have a single build Dockerfile, and whatever the proxy pass that is there in the Nginx web server, that can be passed as a config map, provided you're already externalized that proxy pass in your Tomcat environment.
Sure. Building Docker. Yes, is what I'm doing right now. Building Dockerfile for new deployment. You see, certainly, if it when it comes to different environments like test, production, UAT, etc., the Dockerfile will be the same. Your deployments will be the structure of your deployment will be same. It's actually the values of your config maps or secrets that will get updated that you will have to provide externally, or maybe you will pass your properties file there, as someone mentioned. But the Dockerfile is not going to change. So that's the case. So Dockerfile indeed has to be built if you want to kind of containerize it. Of course, without that, you can't do it. But that said, if you want to change the value every now and then in different environments, all you need is a one Dockerfile, I mean, a Docker image, same Docker image. You need not build multiples. Can we go to the next question?
Right, Shubhan, you can see all the questions in the Q&A box now. All of them.
I see. So we'll take them in that order.
Right.
So the question is, secrets are not secure and easy to hack using echo value base 64 minus G. And there is another question, which is rather, I'll take those two questions together. When do I need some third parties like Vault, for example? So, well, that's true. So secrets, as I showed, when you do kubectl create secret generic credentials as the name I gave to it, the secret, the code to encrypt and decrypt is maintained inside your Kubernetes cluster. But there are other ways, for example, in which you can have your own logic, or you can rather apply on use a standard logic for creating secrets. For example, the way we do even otherwise, you may have a PEM file generated where you will have a public key and a private key, and you can make use of that public key and private key, and you can encode those public keys and private keys in your secrets, and provided you do the required configuration, and that will work. So what happens is you have different cloud providers like Google Cloud, like Azure, AWS, etc., who have their own vaults, who have their own KMS, keying services, which you can make use of. When you do that, the responsibility, or rather the decryption encryption logic, is decided externally. That indeed gets linked to your Kubernetes cluster, because otherwise your deployments will not be able to work. They'll not be able to fetch the real values. But it is certainly not just decodable using base 64 minus G. So the logic, if you were to use a PAM file, a public key or private key, if you were to say go to GCP, create a service account where you use a key vault, where you make use of KMS keys, and then you do the necessary configuration in your cluster. So you'll have a service account associated, and you'll take the service account file, you'll take the you'll do the required you'll take the required KMS key, and then you will incorporate it in your cluster. When you do that, in that case, you may not have those things easily decoded using just base 64 decryption. So just to I did try to answer the next question as well. But yes, so in case you require more secure, I mean, an even more secure service, an even more secure scenario environment. So for example, I may have access to your Kubernetes cluster, and I may like to see your secrets or other files, but I should not be able to do it. And if at all you want to provide an additional level of security, then what you might implement is you might go to GCP, you might create a service account, you might get a GMS key created there, and then you might all encapsulate it in a file, the service account file. And so long as I don't have that service account file available with me, even if I have access to your cluster, I'll not be able to do anything. So that is where third parties help. So we have question like, how about tools like Ant Informatica? So well, this question is I understand Informatica is a data integration tool, but how is this? Can the questioner elaborate more on that? So how does this fit here?
Yeah, can someone elaborate what is this question? How about tools like Ant and Informatica?
Roshan, Roshan, could you elaborate yourself a bit in the Q&A box? Meanwhile, I think we could look at some other questions.
Well, till I think the person who asked the question on Tomcat mentions that he cannot read it from Tomcat, and so if there is something which cannot be made as an environment variable at all, even on your system, that configuration by itself cannot go to that cannot be externalized even from your system to start, but it won't become a configurable thing in Kubernetes. But maybe till Roshan clarifies on his question, maybe I can have the liberty to interpret it in my way till he clarifies. And if the question is that there are, for example, you have services, you have tools where you maybe, for example, you have Informatica, which is a data integration tool where you may be maintaining your environment variables centrally. So Informatica is a data integration tool, and you may create different jobs or transformations there where you may require to maintain your different values. You may have your data source, URL, your password, your username, or the type of connection you want. You may maintain them centrally. For example, Pentaho is another application where you have that facility of maintaining that configuration in a central repository, so that if you have many jobs where the configuration needs to be updated, you don't go to each and every job. You simply update it at one place, and all your jobs read it from there. So as far as the question of maintaining a central configuration is concerned, of course, I mean, any tool like that, be it Informatica or any other thing, any other tool like that will do it. But what we did talk about was rather, for example, containerizing Pentaho and then deploying it. So of course, Pentaho does say Informatica would take care of doing a central configuration, but then uh, what the things for which it does central configuration may still be limited. So it may not do a central configuration of your the amount of heap memory, for example, that you want, or in your data integration application to run. That is not something, for example, which you go and configure in your jobs. That is centrally maintained inside the server. You'll have to go inside the server and change it. Now, going inside the server or going inside your data integration application, going to that server and changing that will may not be an appreciable task in itself. It's rather you Dockerize your application and you provide those values in environment variables. And when you have a Docker image already built for your application, you simply pass those values. Either you pass them as properties file, or you pass them through some Go script or some other script, and those values are internally taken up. So the way I interpreted this question was, yes, you do have applications where there is central configuration, but what I wanted to add to it, no doubt you have central configuration, but there are variables where there are environment variables which are outside the scope of that central configuration, where you may have to go inside your server anyway and do that, which may not be a very attractive thing to do. Better part is to do to containerize and go ahead with using Docker images in your deployments. Any further questions?
Yeah, one more question is there for Kubernetes CI/CD. What is the best tool that we can use? I'll take up this question, Shubham.
Sure.
So if you want to go for a single tool, CI is primarily focused on building the artifacts and ensuring the quality of artifact is there. That is a CI responsibility. A CD responsibility is a deployment, continuous deployment. Okay. So if you want to go for a single tool, Jenkins is the best tool. But if you want to, if you're open to use to separate files, for CI, Jenkins is still preferred. And for CD, Spinnaker is the best tool for the uh, Kubernetes based environments.
Right. So that's all the questions that we have today. Thank you everyone for joining us. Thank you, Suman. Thank you, Shubham. And I'll see you all again in our next session. So
Thank you all. Thank you. Bye.
Thanks, Pranshu. Thanks, everyone. Bye.